How about now? Can y'all hear me now? I'm gonna have to wait a moment and let my audio catch up. Yep. How about now? Sounds like I fixed it. Can y'all hear me now? Anyways, sorry about that. Hey Mike, how's it going? Been missing you, buddy. And I apologize if I mispronounce this. I'm terrible with names. Is it pronounced Izmir? Izmir? But anyways, welcome to the stream. Nice to see you. I guess I'll start over. So, I was just going over the differences between the tanks. The original version, as far as I'm aware, is the RC Speed tank by Bryant. I'll share the screen again. As far as I'm aware, he's the original version. And then it was later remixed by a guy named Stained D or Stained. His version, from what I've seen, has kind of become the more popular, more known version. But I guess your mileage may vary. That's just my personal opinion. I mean, I guess I could compare comments and makes. So 557 comments and 58 makes versus 29 makes, 286 comments. So, in my opinion, the Stained D version has become more common, and it's also what I've based my design off of, because a lot of the parts are unmodified. I won't, say, hey, this is my own design. No, it's a remodeled version of, or a remixed version of Stained D's model and several other people's remixes, just to suit my own needs and do things that I wanted the tank to do. So, let me go back to the comments, just so I can try to keep a better, monitoring of it. So, the chassis here, unlike the Stained D version, the Stain D version didn't have these holes in it, and it had hoops here, but they were too far forward to fit my battery pack. So I wanted to make sure that I wouldn't have to print this part 1,000 times. So I decided to put holes along it, and I could make the entire platform modular. That way I can just literally bolt on what I want to change rather than having to print the main frame of the bed again. So in this case, it's got the rails for my wiring management going up. It'll have some more stuff back here later. But then this piece right here on the holds the Raspberry Pi. Originally, it was just one of these brackets that I found online, and I was just going to screw it to the frame. I decided it didn't need screwed, so I just modified a version of this, or yeah, I think I just modified that, brought out a little lip. So I call this a sled now, the piece that the Pi is mounted on. And the reason I have this lip here is so that whenever I mount my battery pack, it doesn't, slam into the Pi. And I just have this held down by cement, but considering the Pi isn't, doing anything excessive, the cement is fine, and it's actually very secure. Also on the, the main plate, the main frame plate, or whatever you want to call it, chassis plate, Stained, his version had, it had this little swoop here throughout the entire chassis. I modified it to where it just goes back. That way I have more room to work with battery-wise, or any kind of an adapter that I might want to put in there, and I can make it part of the structure of the chassis. I will have the files available once I get everything the way I want it and verify that I've got a good print that I'm happy with. And I'll also make the modified software that I wrote for this available as well. Because most people that built this tank, they use an RC controller of some type. I didn't want to do that because the other purpose for having this version is it has a first-person view. So we have a nice little, here's the front chassis. It is, this is going to be hard. Don't print your stuff out of black if you want to take good pictures, folks. Okay, since I'm not, there we go. Now I can actually see. My other monitor is kind of eh. Okay, so this is based off of the original chassis by Stained, but I modified it to put this little mount here to bolt an FPV camera with, the camera's got a no IR filter and a 160 degree viewing angle, so whenever it's on the tank, it can view all the way to the track, so it can basically see everything immediately around the tank. But then there's these guys for whenever they're infrared spotlights, basically. So whenever the light gets dim enough, these kick on, and you can see in the dark. It works wonderful. And it's actually very subtle. The lights kick on earlier than I'd like, but it doesn't cause any issues. It actually creates a very nice video feed, in my opinion. But what it is the Pi just streams that to a web page on it. So once I'm done, I'll just have one Pi connecting to another Pi directly with, I think it's called Ad Hoc. Basically a direct connection to a direct connection, no router or anything in between it. So this will have a static IP that it'll have both a Python server and a web stream server. The web stream will be displayed on the client Pi, so that you can view the video feed in real time as you're driving the tank. And then the Python server will actually be what does the controlling. I know I'm getting through the technical stuff first before I start actually putting the thing together. So originally I started out with RC speed controllers for the. I bought cheap from AliExpress 540 motors, and I think they're 45 turn. if you know anything about RC. Yeah, so I bought 540 stock motors, 45T, or 45 turn, and what that is if I understand it correctly, it makes the motor slower but more torquey, and it also takes less current compared to a higher RPM motor. Um, okay, so now that I'm no longer trying to show that front chassis, let me pull the comments back up. Yes, the files are compatible with StainD parts, as long as you have oh, what do you call it? I think there's a few parts in here. No. Uh, yeah, pretty much everything's a bolt-on as you see fit. So like this file will be its own thing, and you just swap it out for the chassis part from Stained. Um, this file will be its own thing, and you just swap it out from the chassis part from Stained. And then I have my wheels are another remix. I didn't make my own. I just used someone else's remix. The only other thing I can think of that I contributed. Oh, I have two more things that I modeled myself so far. Three more things I modeled myself so far. One, I'm trying to ruggedize this as much as possible for what its use is. Um, so the original, actually, I've got one of the originals nearby. The original 540 adapter that Stain supplied in his files is that guy. Um, so it works very well. It definitely does what it's needed for. But as you can see, there is, what is that, 6? Yeah, 6 mounting holes. My version has 2. And the reason for that is with me trying to ruggedize it, I'm trying to prevent anything I can. Now, it's not going to be waterproof, but I'm trying to prevent anything from getting into this main chassis area by the time I'm done. I am going to still put a roof, or not a roof, but a lid on this. I have to draw one from scratch. I'm going to, well, not from scratch. I'll base it off of Stain's design likely. But the with the battery and everything I'm putting in here, it won't work. So, but that's the reason for these 2 holes, is to prevent water, mud, or anything if I take this outside, because it'll have 2 uses. One, outside toy. Let's be honest. So I'm the guy that would take something like this through a mud pit. Cover. That's a better word. So eventually I will have a cover for this, but I've got to print one because it's not compatible with my battery pack. Oh, the drivers for this. I originally was going to use RC ESC drivers. I don't know if they're locked for me trying to send the wrong PWM signal, or if when they came into momentary contact with the battery on the signal side, it just fried both of them. Oops. But anyways, I didn't feel too upset because they were cheap drivers, they were noisy drivers, and also they had brakes, if you know anything about RC. So what'll happen is if you're driving your RC and you hit the reverse, it'll engage a brake. And on a tracked vehicle, that would be a nightmare because it's got like a 3-second lockout, I think, before it lets you drive the track again. All right, later, Mike. So instead, I decided to go with Adreno modules. These are H-bridge drivers. It's a very common thing. There's a different driver that's a little more common than these. There's not a lot of documentation on these, so there was a lot of guesswork involved. These ones come with the heatsink on the bottom, which is kind of stupid. I mean, granted, it does pull heat away from the ICs, but they, if you know anything about thermal management, they printed the mask right over the heat transfer plane, so the mask is stopping the heatsink from doing its job anyway. So the heatsink at the time was more of a visual paperweight, is what I will call it. Now, granted, if you sand the mask off, put some thermal transfer media between it, these would be great heat sinks. That's not what they were. So I pulled them off, put some M2, M3 bolts on the other side. Going to not silicone. I'm going to actually, that's not a bad idea. Maybe I should silicone these to protect them. But I'm going to what's the word? Thermal paste. I'm going to put thermal paste between these heat sinks and the ICs. That way they actually function as proper heat sinks. So what these do is they have 2 PWM signals per driver. So there's 2 enable pins, there's 2 PWM pins, which I'll potentially get into that later, or maybe even just make a separate video about it. But basically, you enable both pins to drive it in either direction, but then you send a PWM signal to the direction you would like your RC vehicle to go. So, oh, and another part, I found a gear generator and generated my own gears. I went with the smallest Mod 1 gear I could, and it's still higher of a gear ratio than I wanted, because even though these are slow and stocky motors, this thing's fast. I put a governor into it just so the motors wouldn't turn too much. The other mods that I made was, you know how I said this is a modular chassis. This is the piece that I designed just for my particular use, but I'll make a totally different design for public use. And what it does is it just sits there and reinforces the switches. That way they don't have a lot of stress, they're not bouncing around everywhere, don't accidentally get bumped, stuff like that. There's another piece that goes right here, but I glue it in place, that way I could print this all solid flat. Let's see, and then lastly, the last part I can think of off the top of my head that I made custom is the simplest thing in the world, a gearbox cover. Because I'm trying to ruggedize this and prevent, mud, debris, and everything from getting into this, here's, where the drive sprocket goes. As you can see, you got this big gap open here, you have this gap open here. So you put your motor in, you get it all set the way you want it, and then boom, you mount a little gearbox cover. Now, granted, there is still, clearance issues between everything, but it's a lot more closed up than it was 3 seconds ago. So that'll be another thing file I have up. So I guess on to assembly. Gear mods, wheel mods. These I believe are Edward mods. I'll link everything before I'm done, but these ones, they reduced something on the drive sprockets. I don't remember what, and then he made it to where the 3D, you could put a stylized ring in here. I think he adjusted the depth or the pitch of these to where it engages the track. I found that a lot of people say this design works better, so I decided to go with this. But I printed these on my old printer, and I will eventually reprint all of my wheels. But I wanted to get rid of as much of the layer line as I could, so I made a little jig, threw it on my drill press, ran it in circles, and then just used my drill press like a lathe and applied sandpaper to smooth out the drive sprockets as much as possible. So that's how that'll set in. Is it the Edward wheels? Because I also have the Bogey wheels, but I can't remember who made those. So the Bogies, Stain D, his original version, had sprockets in these, and someone else later on came in and said, that's just causing more issues than it solves. They just remove the inside, and it's just one constant, spinny wheel. Um, I'm not sure how I feel about these wheels for the idlers, which I also have the modified tensioners because of the wheels I'm using or the tracks I'm using. I don't remember. Uh, I'll link everything before I'm done. But these wheels, I'm not a fan of. Here's why. Let me grab the tracks. So I have actually had one or two, no, just one. I've had one wheel crack. And I think it's from the design, but it's also, ow, that hurt. I think it's from the design, but also my old printer, the settings weren't the most optimized. So with the way that this is designed, it's got a wedge on both sides. I'm thinking about redrawing this and just making it to where it's flat. The reason I think that they have the wedge is so that as it's applying pressure to your track, it kind of puts a central pressure to try to force your track to kind of not just tension it in one axis, but kind of apply a better tension. I could be wrong though, but that's my interpretation. The problem is these tracks don't flex. There is a TPU version out there. I haven't tried those. I don't know how well those will work. My tracks are the print in place version. Once again, another remix. So rather than having to print each and every link individually, I think there's 4 bolts in that. So yeah, there's like 4 sections of track, and I think it's like 12 links each track. So those work wonderful. It is a nightmare to print these until you get your printer set in. I killed a lot of these just trying to get everything dialed in, but eventually I did. This is a failed one, but you get the point. It's bolt in one side and then a bolt will go in the other, but it's a print and place track, and it's pretty cool too. I tried a bunch of different kinds of sprockets. Oh, the battery. Battery is pretty simple. It is a 3S 2P, I think. 3S 2P, so 3 18650 cells. I believe they're like 3,000 milliamp hour each. So since there's two, it might even, I might have put 4200s. I don't remember. I haven't charged this thing since I built it, and it's still at like almost 12 volts. But yeah, it's just got a protection board here. I built a spot welder to weld these. It is by no means pretty because this was my experiment one. My next one will be nicer, but this will do the job. I left the contacts open. It's not the best idea because, like I said, I have fried an ESC, but yeah, it looks cooler like this, so don't judge me. But I do already have another protection board ready to go for whenever I get more battery cells. So it's just 2 sets of 3 cells, and then I run nickel plate to them, and it balance charges and protects them from overcharging and over discharging. That being said, I do have a power supply that I can set both current and voltage on, so I do charge these in a controlled manner, even using the BMS. And I know anyone who's an electronics nerd in here will argue whether or not this is a BMS, but it balances, so it's a BMS. Okay, onto the assembly. So as awful as this is going to smell, with me wanting to ruggedize this, I decided to grab some RTV silicone, and I'm going to cut a little notch out of it, and I'm going to run it along the frame as I assemble everything together. That way it'll help prevent water from getting into the bottom half of the hull. Unfortunately, that's a double-edged sword because that'll also prevent water from draining out of the bottom half of the hull. So keep that in mind if you do this. And I have no idea where I set my wire cutters. One moment. Is the music a good volume, by the way? And yes, track assembly is a nightmare. That is especially why I wanted to, print as many of it at once as I could. But also, I didn't want to buy all the bolts for every link. I might. I'm going to try different tracks. I'm either going to try getting TPU and taking my own stab at TPU, or I'm going to get. How do you like this wire cutter? Huh? Just kidding. I'm either going to try my hand at printing TPU, or I'm going to remix these tracks, which again are great tracks, but I'm going to remix them to put TPU inserts into the grooves like someone else did. So just a little insert there, or maybe I'll coat these with like a liquid rubber or something. But yeah, everything I have down here in my basement, it can't grip onto it. It just spins. This was my original, back bracket designed to hold the battery, but I incorporated that into the switch mount. So, and switch. Alright. Oh man, I hate to smell that silicone, but it's a necessary evil for what I want to do. My other parts, I already prepped either all of them or almost all of them. That includes removing what few did have supports, and I also put in, like, punched out holes and whatnot, but also installed all the nuts, or almost all of the nuts. Isn't that just nuts? I'm missing one part though, and that's the switch part here. I think I left it upstairs, so bear with me, I'll be right back. Sorry. Yeah, so the holes, I used M2 holes. I undersized by a little bit. I think like 1.9, 1.8. Sorry, a little out of breath. Kind of this thing called fat. Whenever I made this bracket for the design, I tried with this version first. The part's still printed pretty well, but as you can see, it did fail. I decided to help reinforce the top piece because I really didn't want to use supports, so I wanted this all to be one level. I decided to support the top piece. I was going to put little slots. I was going to, do one of them slot style assemblies. Because of the size and the resolution that I'm using on my printer, it kind of just made globs on here. I mean, it came out pretty well for what it's supposed to be. Sorry that my camera isn't focusing, and I'm too lazy to manually focus it, but you get the point. And then the line width is actually too small on here, so there was overflow into the slots, and it didn't work. So I decided you're not really going to be putting a ton of stress on the switch, so I'll just glue it. But because of the slot, it didn't have a good adhesion to the bed, even with an auto bed leveler, and it lifted, but it still kept printing. So, I mean, if I wasn't putting the top piece on, I would still use this print, honestly, just with, how little of a mess up that is. But I will say, it is strong. Oh, and the other reason for this part, it's not just to hold the battery like forward. It's also the main reason that I started printing this tank is I actually had a fall a while back, and I worked for a cable company at the time. So I told myself after I fell that I'm never going into crawl space again. And that's also how I justified building this with the wife. So what this is for, while I'm no longer in the cable industry, I do still pull lines from time to time for my employer. And what this is for is to tie off a pull string, drive a tank through either a crawl space or a rafter, and pull the pull string behind it. That way I just pull my line through, a plenum space. Never have to move a ceiling tile other than the one at the start and the one at the end. Alright. And I decided rather than, reprint this whole part, I would just cut off the little fingers. This is an interesting music, by the way. I don't know if it's loud enough on the other end, but let's just say it is definitely on the playlist, and there's nothing wrong with it. It's just not me. I'm too lazy to change it. And this is how emergency room visits happen. There we go. Alright, fingers gone. But mine are still attached, don't worry. Alright. So... my headset just died? Ah, it muted my audio. Whatever. There we go. Now I can hear again. There we go. This is different. I like it so far. Now, if I had wanted to go the extra step, which I promise you I didn't, I could have also put a little notch in this for, the locking washer, but I don't think this goes... No, it does not. Okay. But I figured just that locking washer and this nut should be enough for what we're using it for. But yeah, I gave the Raspberry Pi its own dedicated rail. And then I gave the motor drivers one rail to both drivers. It goes parallel, but it's parallel daisy chain, so it goes to the first driver, then it goes from that first driver to the second. And then eventually, whenever I get my second battery built, I'll swap out, this bracket with a proper battery disconnect. But for now, I figure I can just, screw it into the terminal post. There we go. Alright, now I gotta line up. I think it goes back one. I might be off on my measurements. So I might be reprinting that part. That's alright, that's not required for the full assembly. But otherwise, the fitment feels pretty good. That's disappointing. Oh well. Oh yeah, I am one hole off. Whoops. Okay, well, I'll redesign that later. I mean it's not a hard part to print. It took longer to get the dimensions than anything, but that's just a small little rehash. All right. So I guess let's start putting the chassis together because this does have an assembly order. Well, somewhat of an assembly order. So, gotta make sure that the nuts are all in on this side before, assembly starts. Which I made sure of that last night, so. I just gotta make sure that none of them fall out. Best I can tell, everything is still in. Alright. So yeah, everything is still in because you don't want to, start putting this together and then find out that, you missed something. Alright. So. Now I'm going to do my best to avoid the nuts themselves, but I mean, oh man, I did not miss that smell. That's kind of runny. Hopefully that cures. Okay. Okay, now let's make a goopy mess. It smells horrible, by the way. It is RTV silicone. It's my attempt at making this as water resistant as possible. Oh man, is that gross. Not bad. Alright, paper towel time. Like I said, trying to ruggedize as much as possible. I really hope this stuff cures, because that looks like breakdown to me. Oh, right. Gotta get the pieces between it. Because this is actually one of the biggest parts that water could get in. There we go. See? Water can get between those pieces pretty good. Even if you weren't siliconing the rest of this, or sealing rather, I would still probably seal that piece. Just my 2 cents worth. Alright. Okay. This one is literally the hardest bolt to get in and out because, as you can see, it goes down in a triangle. And it'll be even harder than normal because, well, that hole is now filled with silicone. So now if I had like a T-handle, that's what I would use for this, but I never asked for a set because I don't really see a point in it with how little often I use, you know, Allen keys. But yeah, if you had a flexible T-handle, this is where it would be very handy. Because you could just bring it up past the chassis and put it in at an angle if it was like a ball-tipped one. However, I will say, even with silicone, it still feels like it's threading into the hole. So, hey. And I'm not even going to try to get that crap out of there because it'll just make more of a mess with how tight of a fit that is. But so far, here's how we're looking, and looks like the hull is, you know, holding pretty well in my opinion. Alright, I'll wipe this off after I get the other side on. That way I can get a nice consistent motion across it all. Alright. So let me try it a different way this time, just so I can see which way it comes out better. I have a feeling the other way is the better way of the two, but alright. I want to make sure I get that spot really good, because I do not want any water forcing itself up if I do take this in the water. Alright, now the fun part. A placement. And Houston, we have touch. All right, so here. The silicone, once it's dried, as long as it doesn't tear, actually comes off in just one constant pull. The problem is with how thin of a layer I'm making, it'll probably just have a lot of residue. But no, it doesn't have a lot of holding force. It doesn't really, I think it's considered like a hygroscopic material. So it doesn't really stick. It kind of just sits there. Now that's for, you know, this type of material. Now it might stick to PLA because it's a similar molecular structure, but for the most part, silicone, at least RTV silicone, is actually a freaking nightmare to get to stay on surfaces. So while it works way better than putty for sealing water, what I hated about it whenever I was a cable tech was I'd go to fill a hole, like I'd run my cable through a hole and then I'd go to fill the hole with silicone. I couldn't get the silicone to stick to the wall. So that'd be a constant nightmare. Yeah, I got silicone on my hands. Great. My hands will be silky smooth. Yeah, I mean, worst comes to worst, I just have a messy part that I can't get the old silicone off of. So inconvenient and takes away from the aesthetic, but not you know, a functional problem. Sorry. Doing stuff inside the hull is going to be difficult to show from here on out, but... Alright, let's see. How does that look? That's about the best I can give you. My head will probably be a reflector dish. Okay, so far we do have one hole that is being difficult to get started, but it also might be how I have the nut mounted. We'll find out. Feels like it's starting to grab. Oh yeah, it's grabbing. And I set my hand right in silicone. This is the real reason I hate working with this crap. It makes a mess. But it does its job. Naturally, I will be washing my hands after I get this thing fully bolted together. Not the whole tank, but this whole chassis that I'm sealing. Once I'm done sealing everything and bolting the innards, I'm going to get as much as, well, I might have to wash my hands now. Alright. Alright. On to attaching the remaining bolts, which there is 2. And they are a nightmare to get at. So that's one. This way, the farthest one down you see, and then there's another. So once I get those, I'm gonna wash my hands. This one I can probably start by hand. Alright, that one's good. Now, you remember that bolt I said that's the hardest bolt to get in? That's all I got left. least on the chassis. But it is literally the hardest thing to get in. One problem. One big problem. I forgot the center support. Here's what I'll do. I'll do this in a minute. I'm going to get this bottom one bolted down, and then I'm going to pop this part of the hull, like the bottom part of the hull, loose. Actually, you know what? I'll do this. I will loosen this bolt, the farthest up here bolt, and I will loosen these two and try to pull that bottom half just a little out of the way, you know? Please, nothing break. Alright, so now I've got everything except for that one bolt loose, and that, well, I've got everything loose pretty much. This, I don't care if it's weatherproof. It's, you know, it's a structure bar, so I just can't remember. Looks like it goes, yep, that's how it goes, okay. So, alright, boom. It's like it was always there, you know. Just kidding. Alright. I can't remember, that support structure actually might have a hard screw to put in as well. It's been a while, so I honestly don't remember. But I'm going to be removing silicone from my fingers for weeks. Because like I said, the big gloppy stuff, simple. This small, like, film stuff, think of it like trying to get super glue off your hands. It's easy to break the bond compared to super glue, but that's about it. Working on that hardest bolt. Yeah, I thought this bolt was bad enough before. But no, or not removed, but put in. One more half turn and it should be good. Then I'll just check all of my bolts again to make sure I retightened them. Yep. Because you don't want to go too tight on these, because, well, you don't want to split the PLA. And I mean, whenever the frame is properly structured like it is, that's not an issue. All right. Okay. Ow! I just had a GPIO pin go right in the finger. That felt pleasant. Okay. Bleeding a little bit, but shouldn't get the part. It should stay internal. Yeah. It's hard to see without focusing, but it went straight in. Alright, now if I remember correctly, these are these guys. And this is one part that I don't remember if I put the nuts in. That's just nuts. Alright. Yeah, I'll get the central hull. I go get all this crap together and then I'll go wash my hands. Hey, look at that. You injure yourself on stream and you get another viewer. Alright. So the easiest way to do this is put the Allen key along and just kind of go by feel. I bet it muted the music again. Alright. Yeah, this is nowhere near as bad as the one up here is. There we go. And boom, that one's on. And let's do the other side the same. Well, that's new. I'll get that in a moment. There's more silicone up on the front that I apparently missed. So. Alright, so that is on. Looks like it's already starting to cure. It gets real stringy. And then the other reason for those gearbox covers, like here, let me actually tilt this up a little bit since I keep bringing it back. The other reason for the gearbox cover here is I'm actually going to fill this gearbox with a grease whenever I'm done too. So knowing that, let me actually put a dab of silicone in here. Now I don't have the grease yet, so it won't be going in tonight, but a lot of people use white silicone grease. However, from what I understand, that type of silicone grease tends to break PLA down. So I'm not using that. I'm using I think it's called Super Lube. It's supposedly a lot more compatible. So that's what I'm going to try. Whether or not it'll work, who knows? Alright. I'm going to go wash my hands. I will be right back.
Let me go this way, today is my day. God is taking place tonight. Let's all dance and make it shine. Let's all dance and make it shine. God is taking place tonight. Let's all dance and make it shine. God is taking place tonight. Let's all dance and make it shine. Let's all dance and make it shine. Let's all dance and make it shine. I want to escape this crazy life. Yeah. Let me go this way, today is my day. God is taking place tonight. Let's all dance and make it shine. Let's all dance and make it shine.
And I'm back. Oh, I'm making coffee, so I'm back for a moment, gonna go get coffee, and then I'll come back again. Anywho, I will wait to put the wheels on. I don't like silicone. I will wait to put the wheels on, so that it's less to move around while I attach the wires up and everything. The camera is actually pretty simple. All it takes is plugging this guy into this slot. That's why I got the length of wire I did, and that's also the other reason I modified the sled, as I like to call it, the way I did. Because with the way this compartment was originally designed, the Pi couldn't go up forward enough, so this wouldn't work. So I was like, well, I could, modify or I could mount the Pi somewhere else, or I could just remix my own chassis mod. So, ooh, no, 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 we ain't doing that. The socket just tried splitting. Hopefully I don't have to replace this later. And if I do, well, oh well. I hate ZIF sockets. But I think we were able to salvage her. Looks like it's all the way in. Won't know till I go to try the camera. Alright. The fun part. The part that I'm dreading. Putting all of this in. Pre-wired. Okay. So these are going up like this, which means these wires got to go into this. Then I got to mount all these. So what I'm going to do is I will leave these hanging over the front. Hopefully not lay that in a mess of silicone. Actually here, just to make sure that the drivers don't get covered with silicone, which, I mean, it wouldn't harm them if they did. It's more of aesthetics. Alright. Now I've got a screwdriver around here. Not this one. I've got a... who knows where I put it. Screw it. Get it. Screw it. I'm gonna get this bit, and then I'm thinking my coffee should be done, so I'll go grab that and I'll come right back. Alright, how does this fit? Oh, that fits perfect. Alright. So let me take this Allen key. This bit is what I was using for the 2M screws for my modular frame. Alright, be right back. Alright, I'm back. Sorry about that. And let me just make sure I haven't gotten any more comments. Does not look like it. Just checking something real quick. Okay. So, I've got to isolate these wires. Is my headset working? Yes, okay. So, now, the easy way to do this, but not the right way, the easy way would be as if I had pre-soldered all my wires together. But considering I'm using mounting terminals, you actually don't want to solder wires to that. Not to it, but in it. What happens is, especially on like leaded solders like what I use, they have a very low melting temp. So if you run, enough current through it, it doesn't, make it soft enough to like full on flow, but it can cause cracks in the solder from vibrations, but then also um, it will flow a little bit whenever you're under high current draw, um, and then it'll get a poorer and poorer connection and can actually eventually be a fire risk. So don't solder whenever using contact terminals. If you're going to solder, pull the terminals off, solder directly to the PCB, but that's not what we're doing yet. Give me time, I might have to. And I think I'm using 18 gauge wire, which if I was using it for power transmission, I think it's got a limit of 3 amps, but considering I'm using it for chassis wiring, I want to say it's like 18-ish amps, 16-ish amps. And on this rail, or not this rail, but on this rail, I know for sure that I am drawing 10 amps. So I did think about going to 16 AUG or even thicker, but once I looked up the AUG chart and it said that I still had headroom, I'm like, I know they're on the conservative side, so yeah, I'm going to use 18 because it's easier to work with. Otherwise, yes, I would have used a thicker gauge wire, but each motor is pulling 5 amps, 12 volts. So you do the math, 5 times 10, 50, add 2 more, so I'm going to kill a cat. Sorry, I do have 2 cats. They are both very attention driven. 1 second. Alright, so 5 times 10 is 50. Add 10 more and you have 60. So 120 watts just for the motors. But the battery pack is capable of that. The drivers are more than capable of that. Believe it or not, on paper, these drivers are actually capable of like 40 amps each. So, on paper. I honestly don't know what they would actually be able to be capable of. There's a video, well, a guy made a video to where he actually supposedly tested it. I don't know what all he tested or how heavy he pushed it, but I know someone tested it. I just didn't care enough to watch. I was more worried about figuring out the signals. So, sorry, I really like coffee. Okay, anything. All right, have a good night. Thanks for keeping me occupied. Not occupied. Thanks for having like or thanks for giving me someone to talk to and all this. So for anyone who is watching this, I want to open these as far as I can without detaching them from the screw, because they do drop from the screw, which I'm not happy about, but hopefully that's still attached. Alright, so we got positive here, we got positive here, so let's see. Positive is the center terminal, so alright. Tear those apart a little bit more, make it easier to manage. And let's just go ahead and do this. I'm sorry. It's been a long day. Come on. Alright, let's give those a tug. Cool. I like it. Alright, so I know if I try to twist these out here, it just won't end well, so I'm going to go ahead and rotate those around. There we go. Alright. Oop. I just dropped my screwdriver on my cat's head. My bad, dude. Alright. One random strand there. Alright. That actually went on. Well, the wires went on easier than I expected. Now I still got to get these down into the hull. And a pair of claws out of my crotch. Alright. And as you can see, I already kind of made up my own wiring harness, but I should probably take pictures beforehand, that way I can identify what is what once it's down in there. So, alright. Alright, so let me just go ahead and make I don't know what the word is for it, but a note. Yeah, making a note. Alright, so for the right driver, let's just go with VCC is yellow. G is, what color was G? Green. Huh, how about that? Purple is LPWM. Let's see, I'm gonna call that gray is RPWM. And what color is enable? Whatever left is enable. Blue is enable. Alright. Yen is blue. Since it requires both pins to be high to go either way, I just soldered them together. That way only one pin has to turn on for it. Alright, so that is the right driver. Now let's do the left. Alright, VCC. G. Yeah, I'm not going to bother with pictures, I'll just make the notes. RPWM and enable. Alright, let's see. What do we got? What do we got? What do we got? Alright, brown is ground, red is... Okay, so that one I did it simple. Red, brown. Alright, enable is orange. Orange. Orange glad that I'm an idiot. Alright, white is LPWM. And black is RPWM. Right? That looks right. TLR. That looks right. Alright. Bye, Ellie. Cool. Now I can focus a little bit more. Give me 1 second to take another sip of coffee. Alright. Let's do some cable routing. Yay! Which is gonna suck. Alright, I'm thinking it's easiest if I actually hold the motors and then push this guy into place first. These drivers have Velcro on the bottom of them to make it to where they can be removable. That, and I wasn't trying more CAD, just no. that angers me. I wasn't drawing more CAD just to mount these, especially because I couldn't figure out how I would do it with the fact that the motors would have to be out of the way, and I don't have long enough motor wires. So. Alright. One of these is too long, and I can't remember which one. I think it's this one, actually. I didn't think it had. Oh, there's my wire cutters. Cool. I need a new set, but... Alright. There we go. Yeah, let's just feed these in one at a time, then crush it down on both. That's one secured. You know, this wire's longer, it's easier to work with. We'll just move that out. We'll put this one in first. Alright. There we go. Now let's just go ahead and mount these motors and get that out of the way. We can adjust them later, but we'll mount them now. If I remember correctly, this uses these longer bolts. And again, these can be adjusted later, but this at least gets everything started. And YouTube muted me again. I want my music. There we go. So let's put that guy in there. That way we have a pretty good idea. It's hard to fine-tune this before the outside is in place, but I mean, that gives a pretty good idea. Doing this in the GPIOs might be tricky. It'll be a learning experience. Yeah. I believe the nut fell out. Well, it didn't fall out. I forgot to put them in. Huh. Guess you could say I lost my nuts. Alright, there's one. Yeah, I'm sitting there spinning the bolt, and I'm like, I didn't hear anything fall, so I know I didn't knock it out. I didn't knock it out, I just never put it in. Now, I have only actually tested my program with the left analog. And I know the program works. The tricky part is the Raspberry Pi is extremely limited on hardware PWM. I think it's got 2. Well, it's kind of 4, but it's really 2. But for this purpose, it's 4. So I tested 2 of the pins. I did not test the other 2. Alright. But I give you a wired up chassis. Well, I mean, the motors are wired up. PWM, we'll get there. So I actually have to do some Googling. Whoops. So I learned something about the IR LEDs today. This is a focal lens. Here's what the IR LED actually looks like. Oops. So yeah, those will probably get glued on before I'm done. But for now, on she goes. And my cat is a pain. Alright. So bear with me a moment while I look up some PWM pins. However, for those that saw, the beginning of the stream, as you can see, there's only, because of my modified version, there's only, there's obviously the motor housing itself, but there's an edge of a pin or a bolt here, then there's an edge of a bolt here. Otherwise, that's a pretty good sealed chamber in my opinion. The Chamber of Secrets. Oh, sorry. Alright, looking up some PWM pins. Because it actually states in, I think it's the GPIO, or the what is it? PIGS? I call it PIGS, but it's PIGPIO library or something like that. Alright. Here, I'll just do Pi GPIO. Pi GPIO library. And then, actually here. So, like I said, Pi GPIO library. Control F. I think it's hardware. Hardware PWM. Here we go. And this lists out the pins. So, these ones here are totally useless to me because I do not have a compute module. I have an A+. So, we have this pin, all models, but I don't get what it means by the all models but A and B. So, I mean, I guess that's Raspberry Pi 1 A and B. I don't know. I mean, mm, they did change the GPIO in the later ones, so I believe that this is all of them. So let me pull up my script. Hold on. Because I got some stuff in here that I'm not sure I feel comfortable sharing. No, I have some confidential information in my notepad, but okay, so I think I did 12 and 18. Which 12 is on channel 0, and then 18 is also on channel 0. So I wanted to test to make sure that they were separate. What's the word? That they were that the same channel could be used for different directions. So in this case, here, let's see, how do I do that? There we go. All right, so in this case, we have the left joystick, which is pins 14, which I think it's GPIO 14, if I remember correctly, not pin 14. So GPIO 14, GPIO 12, GPIO 18. 14, it doesn't matter. It just has to be able to go high. 12 and 18 do have to be able to output PWM. On an Adreno, I tested this, and I tried using analog pins, not hardware pins, but I tried analog. I tried digital. Neither one of them worked on an Adreno Nano. Now, it was a clone, but neither one of those worked on an Adreno Nano clone. So I'm assuming that it has to be really good PWM signal. So I do have, 2 known pins working. Now let's just see if the other 2 work, and if they do, no problems. Alright, so in this case, channel, or GPIO 13, and let's see, 19, GPIO 19. Those are the numbers. Those are my magic numbers. So now I'm just going to pull up a Raspberry Pi, GPIO, pinout. Alright, I was always a fan of this one. No, it wasn't. That one's garbage. This one. That's the one I like, but I like it when it's rotated, so bear with me. Is that for... There we go. And... Well, actually, no, this works. Alright. So, let's just go ahead and copy this. Paste it into Paint. Because I'm not, not going through all that crap. And the ones that I care about are... Let's see. 1 second. Alright, so we care about GPIO 14. So right now this is one of our enable pins. We care about, let's see, 18. We care about, let's see, 16 one of them? 16, we'll find out if we care enough. Because I might just use 15 for the enable. Alright. 19. We do care about 13. So yeah, we'll probably still use 16. Man, that's gonna be tricky. Tricky. You'll see why whenever we get to the wiring harness. Alright, so easy, bud. Alright, we have 18. Where's 12? Where is 12? Oh, there it is. Alright, so we've got our 1, 2, 3, and 4 PWMs. And we kind of care about that one, but not really. We'll need the 5 volts and we'll need 2 grounds. So let's get the cracking. Okay, I want to see this easier. So, alright. Let's see, I care about this one. Alright, so that's 18, 12, and we'll use blue. Because 12 and 18, then we'll use blue for 13 and 19. And we'll figure that out. Yeah, that motor's coming back off. Alright. One motor up and out of the way, and that gives us most of the GPIOs. Alright, so purple, which is left PWM, or wish I had my funnel code in me. Oh, here we go. RPWM on driver. So FPWM is, well, you know, who cares? I'll remap the pins whenever I get there, as long as they Alright, so purple will be purple will be pin 18. Oh, actually, let's do our positive and negative first. Alright. So first things first, I do know yellow and ground. Or yellow is positive, green is ground. Alright, there's positive. There's ground. Alright, let's see. Purple is LPWM, so let's do enable next. So we'll do blue, immediately one pin next. So we will make blue GPIO 14. Alright, and then, yes, bud, I know, you're there. We will make purple LPWM 18. Actually, we'll make gray PWM 18 because it's a lot shorter. So, what's the next closest one? Oof, 12 all the way at the bottom. Actually, let's see if we can make purple 18. All right, so skip one and then there. All right, 18. I'm gonna kill a cat. All right. Or no, you skip. Alright, and then all the way, so 4 from the bottom, is that what I'm seeing? Yeah, 4 from the bottom. Ugh, that means all the way here. My cat is angry that I won't sit still and let him sleep, but you know what? No one forced him to get on my lap. Alright, so that positive pin pulled off. Fortunately, it's just a positive. Alright. So, let's see, the gray ended up going on 12. And purple ended up going on 18. Cool. Alright. Next. Alright, red and brown. Now, I do believe that these drivers will also run off of 3 volts for the positive, so for the VCC. But why mismatch if you don't have to? You know what I mean? All right. Alright, so we have pin GPIO 13 and 19. Yikes. I kind of want to put this enable pin on 15 just to reinforce those other ones. Alright. So that is now GPIO 15 for enable. So now we just gotta get these 2 remaining PWMs. Alright, so literally the bottom. Skip 2 from the bottom, and then... Yep. I do not enjoy the smell of silicone. There we go. Alright. Actually, it wasn't too bad. Alright. And if I run into issues whereas I'm driving and these bounce off, I'll just solder them on. Alright. There we go. Alright, so black is on 13. And that just means white is on 19. Cool. Alright. Let me pull up, see if any comments have come up. Nope, no comments. Okay. I'm all alone. But anyone who watches this later, there's a nice little close-up of the GPIO headers. So enjoy. Now, if I really wanted to, I could have put, silicone in there. Which I mean, I might, but I would figure that the grease I'm going to be putting, in these will be hygroscopic enough. So there's that. Okay. Holy crap, that means we're done with the wiring and we're on to the chassis assembly. Or rest of the chassis assembly, I guess. Sweet. Silicone's starting to dry. Oh, right. Knew I was forgetting something. Oops. We'll get there in a minute. Some wheels spin better than others. But they all spin fairly well, even for cheap bearings. I thought about trying my hand at, well, I did try my hand at bearings. One, at the time, my machine wasn't tuned enough to do it. Now it's a lot better. I still have some stuff I could do. But what's the word? Bird. No, I wasn't sure how it would hold up long term, and also I'm probably going to get higher quality bearings whenever I reprint these. So yeah. All right, now the fun part. So I'm just checking everything. Alright. Dropped another part on the cat. I don't think this is the size that I need. But maybe. I guess it is. Oops. Well, let me get this mounted on first then. That kind of works. Now, one, if not both of these, I do know has silicone in them, so I don't think it's this one. Oh, nope, it's got some. Which the silicone's already curing. Not cured, but curing, so. It's kind of like a snot consistency right now. Like a really thick snot. There we go. So if the gentleman that was watching this earlier, who went to bed, watches this tomorrow, just look at how easy that was to remove it before it was even finished curing. So now I should be able to, yep. Makes me think of Sonic. The song, I mean, not working on the tank. I mean, that'd be weird. There. Sorry. This is just for reinforcement for right now. Excuse me. That's not bad. I'll tighten it more once I get it on if I need to. So, on to the next beast. This. Uno, dos, tres. Dun, 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 dun. Now, a bolt does go in the here as well. For those that have been keeping track, because the like, oh, where is it? I already lost the guard, or not guard, but the brace, whatever you want to call it. How'd I do that? I'm good at losing things. I already lost my mind a long time ago. Anyways, the piece that sits along here, a bolt goes through each wheel to, hold that bracket on. I don't have bolts for the back one, so I'll get there eventually, but not tonight. I'm looking for the piece that is in my hand. It's like being on the phone and saying, I can't find my phone. Oops. I haven't broken it yet. Welcome back, Mike. All right. These bearings are for fidget spinners and skateboards. Like I said, I did think about printing my own, but I'm going to probably get a higher quality of the same bearings later. I'll get sealed ones, that way I can even pack the wheels if I want. Alright, that's a lot of slop, but believe it or not, these things actually run on almost all the slop in the world. So I will tighten those, and I'm going to start dropping bolts. I'm not gonna lie, that's actually very relaxing, just dropping those guys in. So Alright. Now, the trick I learned on my last chassis. Actually, hold on, before I put that in, well, before I put it in and leave it in, where's my bolts? Ah. I want to see if I have any M4 washers. That way it doesn't squeeze the part so hard. Those washers? Hey, I do. So if these fit, which, never mind, they don't. Otherwise I was going to put those down just to kind of give some kind of standoff from the actual brace. Anywho, one second. Music, 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 music. Yes, I'm still here. There we go. But yeah, see, like I tightened it too tight, so it's actually gotta have like at least half a crack. There you go. It kind of has movement again. Believe it or not, it actually really could use some more looseness. So. Well, that one isn't engaged. Silicone is totally in some of these nuts, but that's cool because I essentially just made my own what's the word for it? Nylon thread lock nuts. So, ooh. Well, hopefully that holds. There we go. Oop, too tight. We got movement. And, like, the tracks move so easily over those wheels without the sprockets in them. I'm honestly just happy if it, has movement. But, I mean, I may want more, so this is where some trial and error will come to play. There we go. And that's with the motor engaged. I forgot something. Well, hopefully this isn't too difficult, but I have a feeling I'll be removing a... Oh yeah, that fits nicely. Now, eventually these... Now, Mike, I don't know if you were here or not, but these are of my own design. Eventually these gearbox housings will be packed with some grease. So this will be A, to help prevent outside crap from getting into that assembly, but also B, to help hold the grease in. Alright. There we go. That is awesome. Alright, so what do you think of the gearbox cover? Like, it's hard to... it's hard to get, a camera angle on, but I feel like that came out pretty nice. Oh, wait, actually, here we go. Here we go now. There. It's a nice little gearbox cover. Alright. Next. Don't repeat the same mistake, Dan. Alright. Now the question is that hole filled with silicone or not? I don't know. There we go. Alright, can you guys still hear me? Hopefully. Headset died, so yeah, I took it off. Hopefully the music isn't too loud. Sorry. Yes, definitely got to use the loop mic. That's one of my cracked ones, but hey, it works. No, there it is. So before I even bother, putting this all on, I'm just going to go ahead and load this idler on. Or not idler, but tensioner. I don't know. I don't know if it's considered an idler if it's fixed. But yeah, it's the idler. Tensioner. Flux capacitor.
Hold on, girl, now wait just a minute. I've got something to say. You should hear it. Oh, I'm happy to make time for your feelings, but you have to admit I already do. Dancing all around till the disco ball drops, but I have to be me, and everyone can see your anger is misplaced, and I'm gonna tell ya, don't hate me 'cause I get attention. Don't turn me into what I'm not. I have to be me 24/7. I ain't never gonna stop. No, 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 no.
Alright, so that tensioner is working pretty good. Oh yeah. Alright.
Tried so many times to tell you this is as good as I can be. Why isn't it enough to be faithful? Also be the hit of
Now,
heartache.
this isn't going to be completely done tonight, but it's going to be drivable. At least that's my goal. And I just realized I forgot a critical part while I wasn't working on the center chassis, so hopefully I can still put it on.
Don't hate me 'cause I get attention. Don't turn me into what I'm not. I have
The antenna.
to be 24/7. I ain't never gonna stop. No, no,
Oops.
never gonna stop. No, 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 no. Yeah, 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 yeah. I ain't never gonna stop. No, no. I ain't never gonna stop. I ain't never gonna stop. Never gonna stop now, baby. Never gonna stop now,
Alright. So there's that side. And yeah. So now I can set the inside. By the way, you guys can make all the jokes you want about lube, but you weren't here whenever I was putting all the white stuff everywhere. Oh yeah, that isn't going anywhere. No, I filled the seams with silicone to try to make it as waterproof or water resistant as possible if I do take it out somewhere. Alrighty. So let me move the camera. Hopefully my face isn't too much of a shine. But there we go. How's that for a glamour shot? Alright. I think I can still get the antenna in there. We'll find out. So I'm using a PCB antenna, and I put what are those, UF connectors? I don't even remember. Alright. I was trying to do this on camera, but it just ain't gonna work.
I think I just got it. Yeah, it's on there. So, I don't feel like getting the microscope out. Otherwise, I'd show you exactly where it is. But, yeah, I put my hand in silicone. Okay. So, what I was saying, which, here, kinda, well, impossible to see, especially since my leg keeps trying to fall. Kind of impossible to see from here, but, alright, yeah, I give up on that. Okay, I do have another pie. Give me 1 second. Okay, so same kind of pie, although, you know, way down in there. This kind of a connector, and I was trying to move past the heat sinks, past all the wires, everything like that, and the pin that I was trying to attach it to is right there on the motherboard, if my camera ever decides to focus. Ah, there we go. But yeah, it's a little jack that's right there, and I was trying to put the wire on the tweezers. It sucked, but I got it. So let's give her some juice after I tuck this wire out of the way. There we go. Alright, so battery pack. Again, functional, not complete. I just gotta keep telling myself that. Alright. Let me turn this music down. It's alright, but it's kind of annoying. Well, rather, this song is kind of annoying. No, that was the song ending, but let's try that. Alright. So, let's see. This is my negative terminal. Which I can't remember the rule. I know there's one first on, last off, or last off, first on. Or, yeah, I don't remember the rule. But there is a rule, and it actually does reduce your spark. I just don't care enough to remember. Alright, and we'll switch the Pi on, and we'll switch the drivers on. Everything's on. Let's see what it looks like. Now, I don't have a direct one-to-one connection yet, so right now it will be going through my router, but that's a good thing for us, because, let me see if I can remember the IP address. So let me just move this out of the way for now. Grab me a fancy little USB keyboard. 1 second. Sign in. Oh, my router pulls my WAN IP now. That's cool. I only gotta, you know, what is my IP? Although I really don't even have to do what is my IP because I have a dynamic DNS. Something else does what is my IP. Alright. I think that's it. Bear with me a minute, sorry. Don't worry about the new version later. And yes, I know my keys can be seen that I'm typing. I just don't care because everything I'm typing is, well, it's pretty standard stuff. It's 192.168.1.139. Yeah, I just gave you a LAN IP address. And yes, it's using the default, you know, password and username. I don't care. Alright, there, slash, etc. Can't remember where I installed my video. Bear with me some more. I'm just looking for one of these days I'll find it. Because I have a feeling I broke it. And I don't know where my video is saved to. Apache 2? That ain't it. Yeah, so it should be. Should be that. Why are you refusing? Alright, let's do a sudo reboot. Maybe you didn't boot properly. Car Python. Yeah, that's not it. I just want to try this. Oh, I think it was this one. It's an older one. It's actually from 2014. No, it wasn't that one actually. Yeah, let's try this video. Actually, I think that is it. It's in front of me, Peter. I'll have it back out in a moment. I'm just working on trying to get something working first. It wouldn't be there, would it? Port previous connection, which well, if it was supposed to be, that's why it no longer is. I mean, I guess I can just reinstall the video streamer. I was going to show the video stream, but I think I might have nuked it. Oops. don't know which one I actually did for the camera stream. I'm just seeing if I can find it, because I'd rather show like the video, but it is what it is. I might just have to come back to the video and wait, RC car over 4G network, is that it? I watched so many of these videos whenever I was trying to figure everything out. Anyways, I'll come back to that. I don't have this set up to do everything automatically yet. So I log in via SSH. I do a sudo. Oh, that's the inactive one. I gotta start a new one because I rebooted the Pi. 92.168.1.139. I think. Yep. All right. Pi, Raspberry, sudo, Pi GPIO daemon. That starts the daemon that allows me to send PWM commands to the GPIO. And then let's see, directory. I believe it's under controllers, so CD controller, directory, tank and client. Okay, so obviously I want client to be on my controller. So give me a second to build a controller real quick. Let's see. Do I have a pre-built Raspbian OS? Let's see if this has Raspbian on it, because I can just transfer the Python from one code to another as long as this all works. So, in this case, let's see what that does. I do have an SSD over there with RetroPie on it, but I don't think I have SSH enabled because I was doing everything locally. Let's see, overhead. Oh, Peter, so that you can see. Would you be talking about, whoops, this tank? He. She ready to play. Play. Yeah, you can even see the because the Pi's on, the IR LEDs are on. They almost never turn off, to be honest. But I mean, with this camera, I don't really care. I might in the future run some wire, like circuitry up to the LEDs to where I can turn them on and off via GPIO. I don't know. I just figured that'd be cool. But yeah, there's the tank. Yes, I just lifted it by the tread. Okay, so let's see if I have another Pi in my ARC table. F5. No Pi. Wonderful. You seem like you probably have Raspbian OS on you. mean, I could start plugging stuff in and actually checking, but that sounds like work. Alright, so next. Yeah, they're 45 turn 540 motors. I have tested them on my multimeter. They are pulling 12 volts, 5 amps. So they big gals. My light is slowly falling. 1 second. The crappy ESCs that came with them. I mean, I got AliExpress specials, but the crappy ESCs that came with them, I accidentally tapped the signal, the PWM signal lines on the open battery, and now they're either in a locked state that I can't figure out how to get them out of, or the battery fried them. Oops. So instead, I moved away from the RC ESC drivers and put in 2 H-bridge modules. Here, well, actually, I don't know if you can see it without the light. But up here, yeah, you can't see jack without that light. But right here, there's 2 H-bridge modules. I have it written down what they are somewhere. I know I was too cheap to go to Hobby King, which, I mean, these modules, they cost me like $13 for the 2 of them. I think the motors were like 15 or 20. I bought the motors and ESCs together, so I don't know what they actually cost by themselves. The motors actually, they sucked at first. They had tons of dead spots. Then I realized that the brushes had oxidized in whatever warehouse that's probably right by the ocean that they were in. Pulled the brushes out, cleaned the brushes, cleaned the contacts. Boom, haven't had a problem since. If they don't hold up long term, I'll get better motors later. But the H-bridges that are driving it, they're cheaper modules, but they're so overbuilt for what I'm using them for. I shouldn't have any issues. I honestly probably didn't even need the heatsink. I only put it on just in case. 1 second. Oh, we have a RetroPie IP address, so that means it's at least connected, and that means it's probably also got a SSH connection, because anytime I connect into the network, I enable SSH. Pi. Raspberry. Okay, we're using RetroPie for our controller, meaning it's already got 6-axis built in. Alright, so let me go back to share screen here in a moment. Alright, share screen. Alright, so here we have RetroPie. That's going to be our remote. It's going to have a PS3 6-axis controller hooked up to it. Then we've got the Tank Raspberry Pi. So I'm going to download my client off of the Tank, because that's where I have it stored right now. So let's see, let's just toss it on my desktop. Toss the client. But also I have to update my Tank file real quick. Because I wrote down right, left enabled is 14. 14. Left FPM is 12, 12, 18. So I didn't touch the left motor. The right motor is 16, 13, 19. 16, 13, 19. Alright, save. Yes. So the way that this is set up, in case you guys weren't here earlier, the one pin with these driver boards have 2 enable pins. However, with the way they're built, both pins have to be high to go either direction, not just one direction. So the enable pins are kind of pointless. So I just have them bridged together and soldered to one GPIO. So one pin for one H bridge, one pin for the other H bridge, just to enable. And then I just send a PWM signal 1 to 255 to whichever direction I want. However, these motors are so freaking torquey. I have my logic is set. My logic here, it's just 255 minus whatever. To where if it's above this value, the max is it goes 255 in either direction, but then the joystick also goes from 0 all the way in one direction up to 255. So I had to do some logic formulation. I'll post my script later. So I don't think I did it here. I think I turned the motors down on the client side. Or I turned them down in the test script. Okay, so yeah, I turned them down on the client on the test script. So let me turn that down because, believe it or not, these are actually way more powerful than I want them to be. So message 1 minus 100, and then let's see, message 1 minus 100, message 1 or message 2 minus 100, message 2 minus 100. For those that know for those that know Python, the way I'm doing this is I'm basically sending a pickle object over a TCP Python connection. That way it's literally as low latency as I possibly can make it. Well, I could do UDP, but in this case I'm treating TCP like UDP because I don't care about a response. So, but yeah, it's TCP Python. So message 1 is the left joystick, message 2 is the right joystick from the client. So, and it's on a range of 0 to 255 PW. Alright, so close, yes. Now I shouldn't have to update the IP address of the tank, but I do have to whenever I connect to the other Raspberry Pi. One second. Alright, my other Pi is 112. Alright. 12. Alright, so I don't care about any of this. What I care about is putting that right there. View and edit. And I don't want to use the link local IP anymore. I want to use the other IP address. So in this case, 192.168.1.139. Save. Upload. Alright, and bear with me. What do you mean, Peter? 255 255 is the max PWM signal for these, but the motors are so torquey, I take 100 off the max value. Okay, so what we're gonna do is we're going to grab this joystick. Sorry, I can't see my thing at the moment, but I'm gonna grab this joystick, pair it to that Pi. Well, here, let me see what I'm actually pointing at. Pair it to this Pi over here, the one that's not in the tank, the one with RetroPie on it, and all right. Now let's pair. Does this mean it's topic related for RetroPie? Alright, so we're as you can tell, we are paired at least USB. I don't feel like figuring out if USB will work or if Bluetooth will work. USB is fine for what I need. So let's start the connection. Alright, directory. We should have, which I don't know if I have Python installed on Raspberry Pi, but Python client. Alright, fdev. Shoot. I forget how to install fdev. Give me 1 second. It's a library that interprets the raw input of the joystick. Well, you know what? Screw it. Let me try this. Whoops. Sudo apt-get install fdev. Nope. Okay. Google install Python fdev. Oh, pip. Okay. But where's the actual? Oh. Pip install fdev. Probably had to run sudo, but maybe not. I don't know what bit I have it set to be honest. Actually, I do. It's in my config somewhere. Because I was told from the Pi GPIO library or Pig GPIO, whatever. The library said above this value didn't work, and I just wanted to copy whatever the Adreno was capable of, because I know these modules were made for the Adreno. Crap, where is that? Oh, that's in my setup on the tank. There we go. Yeah, I set them to 800 hertz. So yeah, and that was actually adding some on to what the Pi or what the Adreno could do, because one of these channels is locked at 800. So I just set them all to 800 so that they matched. Alright, okay, fdev is installed. Let's see if the client starts now. The client starts. And looks like we're running, but I don't have, whoop. Oh, yeah, it can't make a connection. So, no, you're good. I was just explaining it. Alright, so actually, I've learned my lesson the hard way here. Let me go ahead and switch to the fun view. There we go. Alright. And I'm going to go ahead and PYTHON. Whoops, I'm not selected on what I'm trying to type on. THON tank. Alright, so that starts the server. Now let's start the client and see if it can talk. Alright. I think they're talking, but I won't know till I try. Nope. Address is not defined. I haven't tried this on separate pies yet. I don't have a USB to try on this one, because not only is the USB port blocked, it's also dead. Oops. Okay, so let me try changing the tank IP address. Maybe it needs defined. Okay, Bort. I know I got link local to work, so it should just be figuring out whatever the IP address conflict is. And I'm thinking it's because I haven't defined it on the tank. Controller, tank, view, edit, discard, and yes, reload. Alright. IP of vehicle 192.168.1. I think you were .139. Yes. Save. Yes. Alright. Exit the Python library and run a new one. Although it might not work. No, it looks like it's running. Okay. So let me do this. Alright, so now both are running again. That's a little laggy. There's something slowing it down, and I don't know if it's because it's going through my router and not a direct one-to-one, or not being directly hosted, but wait for it. Maybe. I know what it is. Dang client's busted. 1 second. So because this is a 6-axis controller, it actually registers as 2 separate events. So let me log back into the Raspberry Pi. It's trying to look for one event on the Raspberry Pi, or on the controller. The tilt function in the 6-axis controller is an event, and then there's the other event, which is everything else. So I just have to switch the event numbers, and it should fix the client. Okay, so client, view, edit, discard. So let me go back to share screen, reload. Okay, so right now we're looking at event 1. Let's try event 0, which is hilarious, but that is not surprising. Alright, so let me go ahead and Control C, upload, yes, and let me go ahead and start it. There we go. Oh, that's why. Thanks, RetroPie. Found what broke it. I bet it's under event 3, but I forget. So I'm gonna go cd slash dev. Well, I guess I gotta exit out. Cd slash dev input, and yeah. Oh, whoops. Apparently I'm the Center for Disease Control. Alright, directory. Okay, so it's because I'm on RetroPie that it messed up, so it's just that it offset it once. So give me 1 second. Alright, so we are going to set you to event 2. Save. Come on. Upload. And client. Right. Alright, Python client. Alright. So, now let's make sure that... Okay, tilt isn't doing it. Let's go back to overhead. And let me check to see what anyone's saying. Nothing. Shame. Anywho, left joystick. Which, it does have better settings, it's just, I gotta fine tweak the, yeah, the fun stuff. Give me 1 second to figure out what is going on. Oh, that's going to be bad. Oops. It's catching up. My joysticks are inverted, but yeah, it's. I think RetroPie messed up my client. So I can. I guess you could say I have a one-track mind. But yeah, that's with 100 knocked off as far as I'm aware. So because I'm sure people would love to see this thing go full bore. Abort. Controller. Tank. Discard local. Download. Yes. Blah blah blah. And let's drop off the... I'm going to call it a governor. Let's drop off the governor. And control save. Upload. Yes. And stop the tank server. Start the tank server. Start the client. Because as soon as you close that socket, the client freaks out. Alright. I'm just going to hold on. A year and a half later when it works. Maybe. I don't know what's going on. I'm going to regret this. I guess if I really want to know, I just need to build a proper image and test it. But I want to see what's going on. Oh. Did the pie brown out? Yep, pie browned out. That's what's going on. I don't know if the voltage is too low or if I just flicked the power too hard. Oh, yes. If anyone does build this, disclaimer, the H bridges are very sensitive to a sudden reversal. Don't do it. Alright. Alright. Let's see. I'm trying to find the best center of balance, but this thing's so torquey when it kicks on. Alright. I want my music back. I can jam to this. Alright, so you're the client, you're the server, server's busted. Open a new. One 168.1.139. Oh. Ooh, that felt good. I wonder if I tripped the fuse. I forget where the lights are on the A+. Oh, they're there. Yeah, I got no lights, so... Either I tripped a thermal fuse, or maybe the battery's dead? I mean, it's possible. There we go. How about you? What do you got? What do you got? What do you got? 10 volts. That's more than enough to run her. Unless it's kicking off. Alright, so... Yep. There is 1.24 volts out now. So, unfortunately, show's over for tonight, folks. Battery's dead. So I guess I'll have to put my charger together. I mean, it needs it, but yeah. The, let's just say the governor is there for a reason, I promise. So, alright, I am just going to go ahead and end the stream since, I mean, I can't really do anything else with her. But yeah, she's not exactly in the functional state I was hoping for. I was hoping to actually drive it on the floor. But I gotta charge the battery, and I'll build a proper client for the next time I stream. So, alright. Have a good night, all, and thanks for watching. Later.